So we're going to start by just relating multiplication to fractions, and then we're going to kind of dive in a little bit deeper as we go through this. But you'll notice that the multiplication of fractions is no different than any other multiplication. 8 times 4 is 8 times 4, regardless of if you're multiplying fractions, if you're multiplying minutes, kilometers. So don't get too panicky when all of a sudden we have 1/4 times 8. It's going to be the same thing. So please just, if your brain is like, oh my gosh, I'm not quite ready for fractions yet, don't panic. This is actually very similar to what we've already done, okay? So the first one here we have, and they give you these nice little visuals to start out. So these nice little pictures kind of help us through it, which is really nice. In your notebook, I would title this one 3.1 because that's what lesson this is, and that is the lesson that will correspond on Think Central, okay? So I would just put lesson 3.1, new unit. So our first one here says, a path around a large park is 8 kilometers long. Alex ran around the path 4 times. Okay. So you'll notice, and I think this to me is written very weird, 8 taken 4 times is how many kilometers? Basically, he runs the track 8, it sounds really weird to me, 8 kilometers 4 times. How far did he run? Who has any idea on how we would do that? You guys can just go ahead and shout out.
32 kilometers.
And how'd you come up with that?
I times 8 times 4.
Exactly. And I think a lot of this, you guys, the wording is kind of funky, right? But if he runs he'll have an 8 kilometer track right here. He runs it 4 times each time. 8 plus 8 plus 8 plus 8, or like Bella said, 8 times 4 is 32. So they turn it here into 32 kilometers. And you will notice, guys, they're starting to shift over, especially in 5th grade. Sometimes you'll see the traditional multiplication sign, like an X. And you'll notice here, we're starting to see the little multiplication dot. So if you ever see this, it's kind of like a period or a decimal, but you'll notice it's up higher where a multiplication sign would be. That dot can also represent multiplication as well. So if you see this problem right here, don't get too confused. It's the same as a multiplication sign. You'll just notice as you get older, you'll start to see different multiplication signs. But if in your notebook it makes more sense for you to just use this traditional X, that's fine. But just if you see this in your assignments today, or you see it on a test or something, it just means multiplication. So track 8 kilometers 4 times 32. Pretty easy, right? I mean, we've done this a bunch of times. Now, that was Alex. Now we have Kento. Kento ran around the same path 1/4 time. So we have his little visual right here. How would we go about figuring out how far he ran? Any thoughts here?
I know.
What do you think?
You need 4 1/4 to make the whole path.
Mm-hmm. So how many kilometers do you think he ran?
I think he ran 16 kilometers.
Okay, you think he ran 16? Does anyone else have another idea? Any other thoughts? We know that the whole path is 8, right? He only ran 1/4 of it, and I can almost split this up like a clock if I want. So if he ran 1/4 of it, did he run all 8 kilometers? Anybody?
No.
Ridian, why not?
It's a 4th. It's one part.
Yeah, so it's not a whole, right? It's 1/4 of a whole. So Ridian, how many kilometers do you think he ran?
2.
2. And how did you come up with that? Any thoughts?
Well, 8 divided by 4, and since 4 is a fourth, we can kind of say, we can like turn it into a normal 4,
Yeah.
then divide that, and then
So I'm going to give you guys a hint here. If you look at our next problem, and this to me is where fractions get a little bit kludgy and strange. I have 1/4 times 8. There are two different ways you can think about this. And like Radiant said, even though it's multiplication, you can always think of it as division. If I'm taking 8 kilometers and I'm multiplying them by a fourth, they're going to get smaller. So when we're used to multiplication, we're used to numbers getting bigger. But if you're multiplying a whole number by a fraction, it's going to get smaller because you're only taking 1/4 of it. So another way you can think about this is having 8 1/4. So if I was to write this in my notebook, if you guys want, and this might actually really help, 1/4 times 8 would be the same as, and this is going to be a lot, 1/4 plus 1/4 plus 1/4 8 times, right? So why don't you guys take a quick second to write that out in your notebook, and we'll show you how it breaks down. Won't take you guys quite as long as it takes me on the computer. I know anything multiplication means groups of, right? So I have 8 groups of 1/4. And then from there, you guys can pull out your 2 wholes that shows 2 kilometers. So let me, I'm getting caught up here with you guys. 1, 2, 3, 4, 5, 6. Who can explain to me how I have this really long equation right now of 1/4 plus 1/4 plus 1/4, 8 times. Who could explain to me how we get 2 whole kilometers out of this? I just see a lot of fourths right now. How do I get 2 whole kilometers out of this? Let's see. I'd love to hear from Amelia or Justin, Asher, Maddie, Quinn, anyone we haven't heard from yet. How could I get 2 wholes out of this?
4 and 4.
4 and 4. Okay. Oh, so 4/4 you mean? Because look, we know 4/4 is a whole, right? Right here, 4/4, 1 kilometer. Right here, another 4/4, 2 kilometers. So when we start this multiplication of fractions, if it's easier for you guys right now, once it gets too big, it's not going to work. But for the starting point, if you want, you guys can do repeated addition if that's like more comfortable for you at this point. Obviously, once you're multiplying stuff by like 32, this would take forever. But for right now, you can kind of see how this works. 1/4, and please make sure it's in your notebook, 1/4 times 8 is the same as 8 groups of 1/4. You guys know at this point, 4/4 makes a whole. So if I have 8/4, it's 2 kilometers. We're gonna go down to some markers now. Same idea here, okay? So I'm gonna kind of let you try this one on your own first. So we're right here at question 3. Markers come in boxes of 6. Alta has 3 boxes. 6 taken 3 times is how many markers? I don't like this word taken. It doesn't make sense to me. I don't know how you guys feel about it.
Yeah, same.
Doesn't
Taken 3 times. What does that mean? I don't know. What?
sometimes I think they're thinking you grab like you're taking a group of 6, you're taking a group of 6, you're taking a group of 6, but I don't think that makes sense to me. I like this wording better down here, 3 groups of 6. That makes more sense.
Even with my brain, I'm still confused.
It doesn't, the word choice is very poor. Let's hear from, who have I not heard from yet? Justin, could we hear from you on this one? If Alta has groups of 6 for markers and she has 3 groups of them, how many markers does she have?
First, you need to do 3 times 6.
Can you speak up just a little bit louder so we can hear you good?
First, you need to do 3 times 6, and that is 18.
Yes, sir. And why did you do 3 times 6?
Because there are 6 markers in each box. So that's 6. And then we have 3 boxes.
Yep.
So we have 3 groups of 6.
Yes. And that groups of, that is like my favorite for multiplication. Groups of, think of the multiplication sign, right? That always helps.
Yep.
Okay, Justin, I'm going to keep you on for the next one too, okay?
Okay.
So now we have Isabel. And I'm going to erase this a little bit there. So we have Isabel has 1/3 of a box of 6 markers. So this is Isabel down here. She's 1/3 of a box. How many markers would Isabel have? And I know it's pretty obvious because they show it to you here, but is there?
Isabel has 2.
2.
And could you explain why, Justin?
Well, 1/3 is basically just your number divided by 3.
Yes, exactly.
So
Good.
if you divide 6 by 3, you get 2.
Beautiful. 1/3 of a group of 6. So we know if you have a fraction of something, guys, you have less than a whole, right? She doesn't have a whole box of markers. We know she has less than 6 markers because she doesn't have a whole, she's a fraction of that whole. And so like we said, if you guys want, you can look at this multiplication and think of it as division, right? 1/3 of 6. Or 1/3 groups of 6, like it says right here. Because remember that we think of the multiplication sign as groups of. She's 1/3 of a group. She doesn't have a whole group, she's 1/3 of it. So like Justin said, you can think of 1/3 times 6 as 1/3 groups of 6, or 6 divided by 3. Because if I want to find 1/3 of something, I have to divide it by 3. And 6 divided by 3 is 2. Another way you could think about this is, if you're in your brain, you can think of your math facts. These always help. 1/3 of 6. Okay, well, something 3 times equals 6, right? Because 1/3 plus 1/3 plus 1/3 equals 6. So I want you guys to put this in your notebook. Please make sure this relationship statement right here is in your notebook. That 1/3 times 6 is the same as 6 divided by 3. That's really important. You'll definitely want to remember that today. And then also, I'm going to erase this really fast and borrow this spot on the paper. Another way to think about this is, I know if it's thirds, it takes 3 of them to make a whole. I know that 1/3, and that we've done that since probably 3rd grade at this point. We know that 1/3 plus 1/3 plus 1/3 equals a whole, right? So in this case, we know it needs to equal 6. There's 6 markers in total. So I know something plus something plus something equals 6. Well, I know that 2 times 3 is 6, so I know that 2 plus 2 plus 2 equals 6. So 1/3 of 6 is 2. So the more ways you guys can put this in your notebook, the better. I know that for some people, we resonate better with addition. Some people really prefer division. Like at this point, it's however you really want to see it. We're going to get to the point where I tell you, you have to use division, you have to use repeated addition, whatever. But at this point, however your brain sees it best. And if today you guys need to draw pictures while you do your work, also a great strategy, right? It's always a really good way to visualize things. So now we're going to pull away the pictures here, and we're going to do a couple together, and then I'll let you guys move on, okay? So they have it shown multiple ways. So this is what we were just talking about. They're calling them equation chains. Another way I like to think of it kind of is if you guys remember number talks from maybe like 2nd or 3rd grade, where they're like, how many ways can you make this number? Same kind of idea. How many ways can you represent this? So we have as our top example, and I would most definitely write this in your notebook, 1/4 of 8 is our starting point. And then they ask you how many different ways can you show it? Well, I know that 1/4 of 8 is the same as 1/4 times 8. I know that's the same as 8 divided by 4, which we talked about. I know that's the same as 8/4, because you guys know a fraction is the same as division. And then I know that answer is 2. So I want you guys to try number 5 on your own really quick. I'll give you a quick second. And then we'll talk about it. So 1/3 of 9, make it a multiplication equation, make it a division equation, make it a fraction, and then show your answer. So let's do this in our notebooks really quick, and then we'll chat, okay? And then maybe we could even have 1, 2, 3, 4 different people share would probably be nice. Just one person per section of this. So if there's anyone out there that would like to share our fractional multiplication equation that I haven't heard from yet. Let's get started there. Addie, would you like to share for us? We haven't heard from you yet today.
I don't know. Can I go over my answer again?
Yeah, sure. Do you want to talk us through your thinking maybe? So 1/3 of 9. Do you remember, Addie, what we said of can also be?
It can also, no, not really.
Okay, so think of, they wrote just of, but you could also think of groups of, right? If you hear the word groups of, Addie, what do we know that is? Is that addition, multiplication?
Addition.
Okay, well, so in this case, we have 1/3, and I'll write it down here. We started with 1/3 of 9. We know that if we're trying to find a third of something, or we're breaking it down, we're going to be multiplying that fraction times a whole number. And that's my little dot. It should be, it's not a very good dot here. So same with up here, 1/3 of 8 is the same as 1/4 of 8 is 1/4 times 8. So in this case, we're doing the same thing, but we're just doing 1/3 of 9. So 1/3 of 9. So think of, let's draw, and if you guys want to do this in your notebook, this could help you too. I'm going to pretend these are candles. They're going to be really bad. Draw yourself 9 candles. Pretend we're celebrating a birthday. Mine are kind of messy, but you guys could do a better job in your notebooks. So draw yourself 9 candles. And we only are going to be using 1/3 of them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So hopefully in your notebook next to this equation or somewhere near it, you could draw yourself, mine look like French fries. Candles, French fries, whatever you want them to be. All right. So 1/3 of 9. So we said this can be the same as 1/3 times 9. Anyone want to tell me what division statement this would be? What could this be as division?
3 divided by 3. No, 9 divided by 3.
9 divided by 3, good. So what you're telling me, Bella, is that I need to take my 9 candles and I need to split them into 3 groups, right? So what you guys need to do in your notebook is you have 9 candles in total. You need to split them into 3 equal groups. Because she's saying 9 divided by, actually, you know what? I want to do this in a different color. I'll do it in pink for you guys here. Here's 1 group, or 1/3. Here's another group, or 2/3. Here's another group, or 3/3. So now that I have this picture, I know that I'm doing 1/3 of 9, or 9 divided by 3. So here's my 9 candles split into 3 groups. I know that 9 divided by 3 can also be written as 9/3, because that fraction bar just means division. So who can tell me, based on our equations in our picture, what is 1/3 of 9? How much would that be?
3.
3. And how'd you come up with 3?
Because 3 times 3 equals 9.
Wow, see, this is much easier than we thought it was, huh? So 1/3 of 9, or if I had 9 candles and I said, what's 1/3 of them, would be the same as taking my 9 candles and splitting them into 3 groups. 1/3 of 9 is 3. Beautiful work. You guys, is this making a little more sense? You'll notice that, and this is the funniest part about this, is that multiplying fractions by whole numbers tends to kind of freak kids out. Because all of a sudden we have a fraction on one side, a whole number on the other, 2 very different things. We're trying to multiply. Guys, this is basic multiplication and division from 3rd grade. That's all it is.
Kind of like a lion and a tiger making a baby. It's just not right. You're confused about it.
It is confusing, right? Like you look at this and you're like, I shouldn't be multiplying a fraction by a whole number because they're 2 opposite things, right? It's apples and oranges we're trying to multiply here. But when you break it down like this, you see that we are really just doing basic division that we learned 3 years ago. All we're doing is we're taking our whole number and splitting it into that many groups and figuring out how many is in each group. That's all we're doing here. So I'm just going to talk about number 6. You don't actually have to do it. If you want, you could write number 6 down and come back to it in your notebook, but same thing. You're taking 21 and you're splitting it into groups of 7. 1/7 of, or excuse me, you're splitting it into 7 groups. So 21 and 7, hopefully it's triggering something in your brain that's a fact family, right? Oh, I have 21. I split it into 7 groups. How many would be in each group? That's all you're asking yourself here. 1/7 of 21, or 1/7, Rocky, stop. I got a growly dog up here, sorry guys. 1/7 times 21, it's the same thing as if I told you, hey, take 21 divided by 7. Oh, wow. All of a sudden, I look in my brain, I'm like, wow, I know what that means. It's 3. That's it. You guys will notice this is really just going back to your math facts. Always draw a picture if that helps you. So if you wanted on this one to draw 21 sticks or candles or whatever it is, you want to draw dots, whatever. I'm kind of partial to tally marks, but some of you like to draw dots. If you need to draw 21 tally marks and split them into groups, feel free. That works right now, okay? So I'm gonna do one more together, and then I'm gonna let you guys go. So you will notice, you will see comparison bars today. Very, very easy. Comparison bars, fraction bars, same idea, they're just gonna be whole numbers. The comparison bars, I love that we're doing this now because I'll tell you in 6th grade, this becomes a huge thing. So this is a really good step in the right direction. This is the same as doing fractions. Shouldn't be an issue. So we're gonna do this one problem together and then I'm gonna let you guys go do your practice. So to prepare for a family gathering, Sarah and Ryan made soup. Sarah made 2 quarts, Ryan made 6 quarts. So you can compare the amounts using multiplication and division. That's what we just did. Let R equal the number of quarts Ryan made, and let S equal the number of quarts Sarah made. So we're using variables. Hopefully you guys remember variables. It's just a letter that represents an unknown number. So if you see letters in your math equations, don't freak out. Remember, it just kind of means like a question mark. So here's what we've got. Let's put this R equation in our notebook to start. R equals 3 times S. So we have this, we have Ryan equals 3 times S. Could anyone explain to me why they're saying Ryan equals 3 times S? Or where do we get that equation from this problem? Did they just make this up? Did they throw random letters in? Why would we say times 3?
It's because Ryan made 2 times Ryan made 6 quarts.
Mm-hmm.
Sarah made 2 quarts.
Mm-hmm.
Trying to find out the multiplication problem for
Yeah.
how much more Ryan made. How much Ryan made using the variable that Sarah had.
Exactly. And so if you look at this drawing, you guys, you see Ryan has 3 times as many blue pieces as Sarah, right? Sarah has 1 piece or 1 group of 2, and Ryan has 3 groups of 2. We know that 1 times 3 is 3, so he has 3 times as many. So for every 1 quart of soup that Sarah makes, Ryan makes 3 times as many. Or for every 2 quarts that Sarah makes, Ryan makes 6. So if you guys think of it as, I would think of this one best for me, like sometimes with my math, I like to kind of create a picture. And if I was thinking of soup to me doesn't actually look like blue squares of 2. Soup to me comes in like a pot or a bowl, you know? So if say they were making it in a cooking pot, Sarah's cooking pot would only be 2 quarts, right? So if you guys, I would definitely draw this in your notebook, these comparison bars. And then another way to visualize it is, let's say this is Sarah's pot of soup. And you can draw a pot of soup in here with your comparison bars if you want. Here's Sarah's little pot of soup. She's gonna get a little steam coming out of her soup here. Whoo. There's her soup. Sarah's pot of soup is only 2 quarts. But Ryan's pot of soup is 3 times as many. So Ryan's pot of soup might be a little too big-ish. Here's his pot of soup. It would take 3 of Sarah's pots of soup to fill up Ryan's. So if your brain, like some of us can look at that fraction bar and say, or excuse me, in this case, in a comparison bar, and be like, okay, I totally get it. Others of us, and I know this for myself, I need to kind of think of like a real life example. In this example, I think of a big pot of soup. We're going to the party. Sarah's like, hey, here's my small pot of soup. Ryan's like, wow, look at, here's my huge pot of soup. So hopefully that kind of helps you guys like get this visual going. If you need to draw the pictures, draw the pictures. So we said Ryan's equals 3 times Sarah's, or the other equations that could go with this is Sarah's is 1/3 times Ryan's, or Sarah's equals Ryan's times 1/3. So this is exactly how we were saying before. We could write it as multiplication. We could write this as multiplying a fraction, or we could write this as division and taking Ryan's and dividing it by 3. So here's 3 different equations that all mean the exact same thing. So Sarah's equals Ryan's divided by 3, Ryan's equals Sarah's times 3, or Sarah's equals 1/3 times Ryan. So I'm going to leave that there for a second, let you catch up on your notes, and just know that those all mean the same thing. It takes 3 of Sarah's little pots to fill up Ryan's pots. Or if I wanted to take Ryan's and split it into Sarah's, I'd have to have 3 separate pots because it's 3 times as many. Now what we have is we're going to do one drawing together and then we're going to be good to go. And luckily for you guys, a lot of this is on your assignment today, so we've already done a lot of it together. Natasha made 12 quarts of soup and Manuel made 3 quarts. We're going to draw comparison bars to show how much. So in your notebook, you know that Natasha made more than Manuel, right? So let's draw Natasha's first. I'm just going to draw hers as a long one. We know Natasha's is bigger. And we know Manuel's is smaller. Who could tell me how to draw Manuel's comparison bar? How would I use this 3 and 12? What kind of comparison do we have going on here?
You can put you can just do that and then put an M for manuals, I think it is.
And how big should I make his though?
Half, a little bit lower than a half of Natasha.
So we know Natasha made 12, right? So if I split Natasha's in half, how many would each of these be? What's half of 12? Anyone?
6.
6, right? Okay, well, Manuel did not make 6, he made 3. So he made 1/4 of what Natasha made. So Manuel right here, he made 3. So here's Manuel's. And we know that Manuel, if he's only making 3, it takes 4 of his to make Natasha's. Because 3 times 4 is 12. So there's our little comparison bars. Manuel made 3. Natasha made 12 altogether. I know that 3 times 4 is 12. If you guys wanted to look at these comparison bars as division, you could just look at this and say 12 divided by 3 equals 4. That's it. This is literally going back to our math facts from 3rd grade. And then you just have to complete the equations on it. Blank, and I want to hear from someone I haven't heard from yet. So let's see. I'd love to hear from Gio or Asher or Rocky or Tyler. Blank, so somebody made 4 times as many quarts as somebody else. So who made the 4 times more?
Natasha.
Natasha, and how'd you figure out Natasha? I'm just gonna put an N.
Because she has more than Manuel.
Yeah,
Like
exactly.
more.
Okay. So I'm gonna say N made 4 times as many quarts than M. 4 times as many, 4 times more, exactly. Now, somebody made 1/4 as many quarts as somebody. Could you flip that around for us, Millie?
It was Manuel, and then
Made
made
1/4.
1/4 as many as Noel.
Look,
Natasha.
yeah, you're good. So guys, this multiplying fractions is really division. That's what this is. So if I was to say 1/3, or 1/4, excuse me, which is what Manuel made, 1/4 times 12. So if I said Manuel made 1/4 as much as Natasha's 12 cups, he made 3. And you guys know this is the same as 12 divided by 4 equals 3. Are we starting to see the relationship here? I hope. If you need to use drawings today, use your drawings. If you want to use these comparison bars, these are super helpful too. So what you could do here is if I had let's say I was just given this equation. 1/4 times 12. That's it. I didn't know what Manuel made. I had to solve for it. So let's say, and you will see this today. I'm going to erase this really quick for you. If I saw 1/4 times 12, what I could do is I could, oh, sorry guys, my mouse is running out of batteries. There we go. 1/4 times 12. I could, if I wanted, I could draw 12 sticks or dots and split them into groups of 4 and figure out how many are in each group. Or if I like the comparison bars, I could do, say this is a 12, split it into fourths, right? And then I know that 3 times 4 is 12. So those are kind of two different strategies you could use today. You could use your sticks and dots if that really helps you and you want to do it that way. You could use your comparison bars and split it into 4 equal groups. Or if you like to see it as division, that is also super easy. 12 divided by 4 equals 3. So there's a lot of different ways to go about this, but at the end of the day, you are splitting 12 into 4 groups, okay? All right, let me exit out of this. I'll give you guys a quick second if you want to write this down a couple different ways. So 1/4 times 12 could be 12 divided by 4. It could also be a fraction or a comparison bar of 12 split into 4 groups. Or 1, 2, this is going to take me a while, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, well, I know I need to split it into 4 groups. I would have 4 groups of 3. And hopefully in your notebook, it looks a lot better than on my screen. So there's a couple different ways you guys could go about this. Again, whatever way is most comfortable for you. If you're like, I just like using my math facts, I just want to divide, go for it. If you really like using these comparison bars, great. If you still want to circle your groups for today, no worries. You will see comparison bars today, so you'll have to know what they mean. But if that's not the strategy for you, you just have to know how to do it and move on, okay?